Hello and welcome to 5 Minute Math. Today we are looking at Algebra 1 Standard A.7C. Specifically, we're looking at some activities that teachers can use to help reinforce this concept with their students. This is actually off a blog post on my website, 5minutemath.net. I will make sure to put the link in the description to this video. You also see it at the top of the screen. So what we'll see here on this blog post, first we're going to start with the actual standard itself, 8.7c, and this is just the regular 5-minute teaching video that I have for this. The reason I wanted to make some activities for this is because on the 2023 STAR test, this was tested one time, number 38, and you see we only had 30% of our students get full credit. Here's the actual problem. All they had to do was to see what were the coordinates of the new vertex going to be if you had this x minus 3 and then minus 9, right? And the answer here would be positive 3 and then negative 9. But students had to do a drag and drop. They couldn't do multiple choice. And only 30% of our students were able to see that the vertex of the graph would be moved to the right 3 units because of this 3 right here, and then down 9 units because of that negative 9 down there. That's an explanation of that particular problem. So how do we review this in a way that's active and playful? Well, I wanted to incorporate the 6 principles of active playful learning here: active, engaging, meaningful, social, iterative, and joyful. Because if it's not fun, then there's really not much point doing it. I think math and joy do not have to be separate. And I think students learn a lot more when they're enjoying and just having fun. So these are just a few principles of what I'm trying to follow here. And let's get to the activities. So some of these you might have already thought of, some of these might be brand new. So my hope here is just to spark some ideas, right? So the first thing we could do is we can play Desmos tic-tac-toe. So on an interactive whiteboard, right, open up a graph on Desmos, and I've got one right here. And what you want to do here, I'm going to switch back and forth. You want to change the settings here. I just arbitrarily chose some settings on the x-axis and the y-axis here. Change the step to 3. You see I've got some boundaries right here for the x-axis and boundaries here for the y-axis. And this is what it looks like. It looks like a 3 by 3 tic-tac-toe board, but you see that I'm going to keep everything as integers, but what I'm going to do is I'm going to uh, allow the students multiple ways to kind of land within those squares. So that's the settings right there. And what I'm going to do is I'm just going to let students submit, equations, right? So this first equation might be x minus 1 squared minus 4. So this would be an x right here in this board right here. And then the next team might choose the middle square. So they'd have to give me an equation that hits within the middle of that board. So that would be a 0. And you might say that any equation that lands on the line, like if it lands right here or on an intersection of the major lines, it's just not going to count. And then you would want to maybe, if this is on interactive whiteboard, really emphasize these boundary lines so they see the 3 by 3 grid. And as we see the students play, right, we see that I've got 2 going right here, and maybe this team isn't a great tic-tac-toe, so they're going up right there. And obviously, what we want is we want something right down there. And so we're going to see that right there, and the red team would win tic-tac-toe 3 in a row. So that's just one activity, right? You can split them into teams, and that's just an example of what we just looked at. Now, we can also play with some variations, right? Obviously, I just arbitrarily chose those boundaries for my graph here as, between 0 and 9, between -6 and 3. Change that to whatever you want to focus on moving the graph into various quadrants. Like if you want everything to be negative on the x-axis, right, you would shift this over. You can allow a time limit on each team submission if you want to kind of up the challenge a little bit. You can shrink the quadrants, right? So I made these pretty generous quadrants, but you can shrink them so there's only, 1 or 2 actual correct answers to land within those quadrants. If you want, you can have one team submit functions that open upward and one team submit functions that open downward. They'd have to reflect over the x-axis. And then you can play a little battleship if you want to. You can have, this is a little bit more advanced, but have them on graph paper submit where they would want their ships to go, and then they would have to try to knock out their enemy ships. everything being integers, and wherever the vertex is, that's where the hit would be. So that's just one activity for A.7C. Let's look at our next one, transformation hot potato. And so we want students to recognize the changes on the parent function here. Now, this is a little bit more physical interactive, so you want some floor tiles, something like if you have anything like this in your room, just your traditional 1 by 1 floor tiles, you can actually do it on the floor tiles. If you don't, that's fine. You can use chart paper, something like that. Here are some just basic boundaries that you would want. The X and Y axis would be limited between -5 and 5. Now, here are the game cards you're wanting. These game cards are a little bit simpler, right? So here's your basic parent function right here. And you notice that I'm just moving the vertex either horizontally or vertically right here. And you see I've just got a whole bunch of different ones right here. I also have some stretches or some compressions or some reflections right here. So those are the different options right there. And then I do have the answer key. These are the game cards. So what you can do here is you can have the student stand right there on the floor tiles there, and their job is to flip these game cards over one at a time, and they're supposed to physically move that parabola's vertex based on the transformation noted, right? So they discard the card. So this first team, if you get uh, f of x minus 1, they would move the vertex, 1 to the right. If you got this one right here, they would move it, 1 to the left. And then here we're moving it down 3. So what you're trying to do for this game is you are trying to, if there are 4 teams and each team is taking a quadrant, the goal is to not have it in your quadrant by the end. So you're trying to play hot potato. You want to move this vertex away from you, and whichever team has it in their vertex in their quadrant when the game is over loses, right? And when you're not moving it, if you have an asterisk, you simply need to describe it, and then it tells you how much to move, right? So if you see here, okay, so we are going to stretch here, then you're going to move 1. And you would move 2 if you see here that you are going to reflect it over the x-axis. And you see we've got all the choices, the correct answers down here, stretches or widens, narrows, and all that business. So your goal is simply to push it around. Now, here are some variations. Instead of having them flip over one at a time, you can make it a little bit more strategic. So let them look at their cards like they're playing, a game of Uno or Goldfish or something. They get to select one card at a time. You could have them play on a timer. And instead of going through each card once, they just keep going. They reshuffle, and then the play stops when the timer goes off. Remember, the point of the game is just to not have it in your quadrant when the game is over. You can play 2 cards at once if you really want to slam it into someone's quadrant, but then you miss your next turn. And then you could have a student rather than that function card up here represent the basic parent function. So that student moves around, represents the vertex. You can place hotspots on the coordinate grid, and if the vertex lands on the coordinate grid, uh, they automatically win. Or if you don't want the game to be over that soon, if you land on that hot spot, then that team gets to go again or gets to move it 4 spaces in any direction. And then you could flip the equations in the descriptions. You can create your own game cards to where uh, the card describes the movement, and the students can only move it if they write the correct equation. So maybe the card says move the vertex 1 unit to the right. The students would then have to write this equation right here in order to move it. So there's a lot of different variations there. So here's another idea, transformation 2-step. This also is going to get students up and moving because that really helps them physically represent the vertex, and it's also active and playful. So you want some game cards either from Transformation Hot Potato that we just looked at, or you can create your own set of similar equations, and you want them standing in columns and rows. So you are going to need a little bit of space. This might be outside, this might be hallway, gym, cafeteria. You're going to show an equation from the game card, and then they're going to move in that indicated direction, right? So if you are looking at this particular equation, right, you're going to want them to move to the right just 1 step. This would be 2 steps, 3 steps, right? And then if they are going to move down 3, right? That's going to be backwards 3, whereas this would be upwards 2, so they're going to move forwards 2. Now, there are going to be some times in which you might want them to not necessarily move in a direction, but have some other type of transformation. So if they reflect over the x-axis, right, it's a negative outside of that x squared, then you would have them turn around 180 degrees. If you want them to stretch the parent function, right, then you would have them spread their arms out, their arms and legs, making an X shape. If they want them to narrow, you're going to put their arms and feet together, standing stiff as a board. So they're just going to physically represent what's happening to that parent function, and that's it. It's just an activity to kind of get up and just see if they can use their bodies to represent what happens to this parent function. Now, there are some variations if you want to make it a little bit more challenging. You are going to have some students that struggle with this, so they're just going to watch their friends. So if you want, you can show an equation, count down from 3, 2, 1, go, and then everyone do it at once, right? That, trust me, will generate a lot of laughter as some students do it right, some students do it wrong, but that will make it a little bit more interesting. If they're confident, they can close their eyes and they can remove that visual confirmation of their peers. They can write their own equations and share them, checking and be sure that their classmates are correct, right? So the student, instead of using the game cards, have a student stand up there, write an equation, and then reveal that equation and see if everyone moves the way they thought they were going to move. You can put a hot spot on the ground, and they're trying to either hit that hot spot or move to that hot spot based on how the array moves. And you could do it in your desks seated if you have your, chairs and columns and rows. Now, we can also play Go Fish. So this is one where we're matching the effect of the transformation, but we're matching it with a graph, with an equation, and with a verbal description. This is a different set of game cards here. These are the Go Fish game cards. You're going to see they're color coded here. So all of my graphical representations are in red, my equations are in yellow, and then my verbal descriptions, which is just in writing, are in blue. And I just made a different set here on 6 different pages, so a total of 12 different books. And then we have just a visual reference of just the parent function right here, right? So everything is being compared to this right here. So how do we play Go Fish? Well, it's just basic Go Fish rules. You have in pairs, maybe groups of 3. You can have larger than that, but the game's going to go pretty quick. You might want to keep an extra set of game cards for the answer key, in case students can argue about whether or not they have a book or not. But each student starts with 5 cards in their hand. The remaining cards are the fishing pile, and their job is to make a book of 3 rather than 4. And it's supposed to be one red, one yellow, one blue. That's a graph, an equation, and a description. And what they're going to do is they're going to ask, a specific player for a graph or equation or description that matches one of theirs. And if they have it, that's great. They get it. If they don't, they draw a card from the fishing pile. When the fishing pile is empty, they don't, and they don't get a match. They don't draw a new card. They just keep playing until all the books have been made. Then the student with the most book wins. So basic Go Fish rules. So here's an example. Now, how do we make this a little bit more challenging? A lot of kids are going to want to share their picture with their friends, saying, I want one that matches this. Well, for an added challenge, don't let them show their cards. They need to describe it, right? So they might want to say, and this description right here is from this image you see right here. The graph is flipped over, pointing down. It's moved up 4 units, but not to the left or the right. Also, it looks skinnier or narrower. So they're going to try to give you some verbal descriptions here. And if you want, they might be able to say this is going to be a negative, and it's going to be, a narrowing. So it's going to be like a 2x, and then it's going to be a +4 because the vertex is moved up. So see if they can describe what they're seeing rather than just showing the rest of the group their card. They can instead play memory match rather than playing Go Fish. They can just play a huge memory match game, but you'd have to get 3 in a row, right? So instead of doing just flipping up 2 cards, they'd have to try to get all 3 at one time. So they'd flip 3 cards at a time. If you want to just focus on something, you can remove from the deck all the graphs or all the equations or the verbal descriptions. So let's take out all of the reds. You just want them to match the yellows and the blues. So maybe you just want that to be their focus. You have that scaffold of that that parent function there. in case you want some students to really focus on the difference between this and one of these. They might need that as a scaffold there. And then play, you can print out multiple sets. You might need to note them on the back to keep them separate and just have pairs or groups of three just race, right, to where they're trying to match them all up and see how quickly they can match up the 12 different sets. Finally, we've got Desmos sliders, and this is an interactive activity. So you want students to be on their Chromebooks or their netbooks or whatever they're using here. You are going to definitely be modeling this on your interactive whiteboard. And what you want is you want to have students on Desmos, and let's just say you're wanting to work on moving the graph up and down. So you would have this on the interactive whiteboard, but each student, pair of students, maybe even three students, would have this on their own device. And you might say, and you're going to type this in right here, and you might say, all right, guys, what would it take for me to move this graph 2 units up? And so what you want them to see is if I move this slider up, you see how it's moving up 2, and you'd want to say, okay, if I change this d to 2, now I've got my new function of x squared plus 2, and my new coordinate for my vertex would be 0, 2. Now, all this does is this lets them manipulate and see what happens. All right, so this is how we change it up or down. Now, very common is you might want to have it move up or down and left or right. So if you just type in minus C, it's gonna give you this option of adding that C slider. So you might say, all right, what would it take for me to change the vertex to +2, +4? Okay, so what we want to do here is we want to maybe do this, and then we move this up to +4. And so what you're doing is you're giving them an equation or you're giving them a verbal description, and then you're going to let the students themselves go ahead and um, do it on their computer, on their device, and then you reveal it on the big computer, on the interactive whiteboard, so that they can see what's going on. And really, this is just letting them play with it so that they can see what happens. And you notice this is in the minus C, right? So when the C becomes negative, right, it's going to end up being this equation right here is going to be x minus -4. So they need to know that that's going to look like x plus 4 is when it goes into the -4. So that's something that students need to keep track of. So that's how you would just interact with that, and you just repeat with various other transformations. So maybe you want to play with an a in front of the x squared. You want to play with that b within the x before it gets squared. Now, what are some variations? So you can have the students, if they want, they can keep, right? So let's go ahead and just keep something as a visual reference. And so what I want to do is I want to just play with that. And then let's just keep the y equals x squared. I'm not going to do anything with it, but you want them to play with this right here and just to see how the parent function stays there and what you're doing to the child function by manipulating variables. That's one option. You can work with two transformational sliders at once. That's what I just showed you, right? Where you can play with two at once. So I just did the minus b plus d. And you can allow a student to lead the class, right? Let them take over the teacher computer and they call out transformation and have their class match it. Maybe have the screen off while the new teacher sets up, or the child in this case, sets up the transformation and turn it back on for the class to check their work. Something as simple as this. It's not even a competition, but they would love standing in front of the class and trying to get their classmates to match what they have. Finally, if you really want to mess with kids, right, give them all four sliders at once, right? So you see the A and then the B within and then the minus C plus D. Now, this is what you want them to notice. I'm just going to manipulate this B right here. And you want them to notice that if you want to widen it, right, it has to be between 0 and 1. If it goes to 0, obviously it's going to flatten out, right, because it's going to take out the x. It would be 0 times x. If you go to negative, it widens. But take a look. Once I get past -1, it's going to narrow. but it's negative. And you want them to notice that since that b is within this parentheses, it's going to be negative 6x, and then that's going to square it. And the negative 6 is going to be squared, so it's going to end up being a positive 36. So if that b becomes negative, it stays positive. There's no way to manipulate this b by itself and make it reflect over the y-axis. This a on the outside can definitely reflect over the y-axis. So that's something you want them to notice there. So you can really mess with the kids and let them just manipulate this if they have all four sliders at once. So that's something that you can play with, and you can just have them have some fun with that.